Welcome to Section 6, Analyzing Big Data. In this section, we will start the journey towards this real-time natural language processing solution by setting up and preparing for our use case, the focus being on data exploration and data acquisition. We will start in this section in the first video called Natural Language Processing with Spark, where I will introduce you to what I call a structured approach to big data analysis. This will allow us to prepare and explore our use case in a detailed fashion. We will also explore how Spark handles natural language processing and how we are going to handle sentiment analysis with Spark. Then, in video 2, Identifying Our Data, we focus on data identification and data acquisition and start collecting the data we need to train a sentiment analysis model on. The third video, Data Preparation and Exploration, will be focused on data exploration. You will learn additional tips and tricks on how the Spark lab environment can be effectively used for exploring a dataset, focusing heavily on the interaction between Pandas and PySpark. We will also get to see how data visualization can be done using Seaborn. And then finally, we will round off this section with the fourth video, creating our raw training data, by ensuring our data is ready for use and ready for cleaning. So by the end of this section, you will have a thorough understanding of how Spark interacts with Pandas and how you can approach data exploration and data acquisition with PySpark. We will have set ourselves up for the next phase in building a streaming sentiment analysis solution. Welcome to the video, Natural Language Processing with Spark. In this video, I will be showing you how to approach a use case with Spark. We will talk about a process to go by while setting up an analytics application, and then we will zoom in on how Spark handles natural language processing. I'd like to start by sharing how I approach data science and advanced analytics projects. With this slide, I attempted to visualize the process of getting from data to intelligence to action. In the end, what we want is actionable data. So the process. First, we start with an initiate phase. The business case is leading in shaping the requirements and determining a solution. So we start by building a thorough understanding of the resources that will be utilized and which business challenges we will tackle. Then, we identify the data sets that we require for successful completion of the data analysis. The step I have not specifically highlighted here on this slide is that of research. Because I'm assuming that while we are identifying our data and evaluating our business case, we will also do the necessary research in order to familiarize ourselves with the use case and the analytics at hand and what is possible. Next, you get to the prepare step. So once you have finished your initiation step, we start by acquiring our data. So this means that we explore it, we record the findings from our exploration, and we determine their usability. And also we will store it in a place where we can access it prior to doing the next step, which is the cleansing. Next, we put what we learned from acquiring our data into practice, and we move on to cleaning the data. This means that we clean and transform and unify our data. So our data is validated, we handle missing values, we make sure that our outliers are identified, we make sure that noise is filtered out, and we make sure that duplicate records are removed where necessary. So we transform and we denormalize where we need, and we also store the format where we can use it later once again. This time, the data, however, will be clean and ready for analysis. And finally, once we've done all that, we make sure that we integrate data sets when we have more than one, so that we arrive at a unified view of that. So the resulting data should be ready to use for our analysis step. So once we've done all that, once we have our data ready, we go to the analyze phase. This is an iterative process that may involve techniques with a varying degree of difficulty. So what we do is we select the model or the models to use, and we train and we tune them. Then we set out to find hidden patterns or correlations, to test a hypothesis, or to build our predictive model. And then we determine how and where the results in the analysis can be implemented in such a way that our business case is met. The output of the analyze step should be a defined, tuned, and trained model that we can use further down. And then we get to the implement phase, which is the final phase of this model. When we get to this phase, the idea is that we have models that are deployable, and we go and actually deploy them. So the outputs that we generate here, they should be able to be integrated with other systems. Actions can then be defined to directly influence the behavior of people, or implemented and integrated with other pieces of application that can be exposed. So this is a very simplified way of, let's just say, call it a 12-step program that I follow in order to be successful with advanced analytics. And this is a very important thing because once you are dealing with Spark, what I will show you in the later hands-on videos is that once you're dealing with the data acquisition, you're not always dealing with the same data as what you're actually going to be using in production. So let us zoom in on our use case, and I will explain to you what that means. Let's start with our business case evaluation by looking at the business case that we're going to be working on throughout this section. So our use case is to build a solution capable of performing real-time sentiment analysis for a given topic on social media, for which we will deploy natural language processing and Spark streaming. So let's reread this. If we reread this case description and interpret them as required, our solution must be able to follow a given topic on social media. And then our solution should be real time. And also it says our solution should be scalable and we should use natural language processing and Spark streaming. Those are the requirements that are set out for our use case. So what we then do in the business case evaluation is we again look and see what are the decisions that we're going to make, what are the concessions that we're going to make, and what is possible. So what we're going to do is we're going to be implementing this initially as a functional proof of concept, right? So we're not going to build a production-ready system out of the box. Let's just assume that's good enough for this use case. We're going to be implementing a functional proof of concept. This leads us to some decisions that we're going to make. So we're going to use Twitter for our implementation for the simple reason that the data on Twitter is the most reachable and open of all social media platforms. And this is perfect for the proof of concept setting that we are in. Also, real time is mentioned, and real time can have many meanings. It can range from fast enough to almost instant. So let's assume we get away with fast enough here and set our threshold at roughly about 30 seconds. Since we're running on our small local machines here, any more than that just is not realistic. And the additional requirement was that of scalability. So we have the requirement of scale. And this is where, all in all, it's perfect for using Spark. Because when using Spark, we can get our proof of concept done. We can do it small scale. But then we can still take the solution and really easily scale this to a real world scenario, much larger on a much larger cluster. Okay, so this is how we're going to approach this. We have our use case. So before we continue, let's talk about what we're actually going to do. We're going to be working with what is called sentiment analysis. So what is it and what can we use this for? So I've turned to definitions.net again, my go-to dictionary for these things, and it gives us a beautiful explanation. It reads, sentiment analysis refers to the use of natural language processing, text analysis, and computational linguistics to identify and extract subjective information in source materials. Generally speaking, sentiment analysis aims to determine the attitude of a speaker or a writer with respect to some topic or the overall contextual polarity of a document. The attitude may be his or her judgment or evaluation, affective state, or the intended emotional communication. That is a lot of words. If you just put this in layman terms, what it really says is that we are mathematically quantifying the attitude of an author of a given body of text. In our case, in the use case that we're going to be doing, since we're going to be quantifying our sentiments of users leaving tweets, this means that basically we're putting a number on how positive or negative people are while they're writing the tweet. That's what we're going to be doing. Sentiment analysis is part of the larger subgroup of data science called natural language processing. So natural language processing as a field of science is actually very broad and it contains much more than just this sentiment analysis. So when we look at NLP, which is usually how they abbreviate it, we can actually find that it's all around us. So if you happen to own an iPhone, for example, you must have interacted with Siri before, or perhaps you have interacted with Alexa on an Amazon Echo device, or maybe the Google Assistant if you have one of those. All of these digital assistants are examples of advanced natural language processing put to practice. But even things like the news feed that you might see on your Facebook or your LinkedIn, they also use natural language processing to determine what you might like or dislike. So some of the techniques used by these solutions are very advanced, of course. But in general, natural language processing includes things like text-to-speech, context extraction, topic modeling, automatic summarization, speech recognition, stemming, and oh so many more things. I've included 2 links here that I'll link to Wikipedia. Over there you can find that there are some nice write-ups with lots and lots of links and reference material if you're interested to learning more. For me personally, natural language processing is one of my favorite fields of data science. So now let's have another look at Spark and see what it brings to the table regarding this field of science. So when we were building our recommender system a couple sections ago, I introduced you to Spark's dedicated recommender module, and we got to use it as an introduction to Spark's MLlib syntax and learned how to apply it in code. What it also showed is how convenient it is to have a dedicated module for handling specific machine learning tasks. However, unlike the recommender module, there simply is not a singularly purposed dedicated natural language processing module available in Spark MLlib. This means that you have to take a more hands-off, directed and manual approach while implementing a use case like the one we have here. So this in turn means you're going to need to know your way around Spark MLlib quite a bit better than before, which is the reason I zoomed in on all the various aspects of Spark MLlib in the last section. An important thing to realize though is that not every single natural language processing use case will be solvable with just Spark. Hence, when you try to implement more advanced natural language processing functionality into your Spark pipeline, you could run into the issue that you need to use other NLP libraries to accomplish certain tasks and then try to feature intermediary steps back into Spark. But splitting your data processing framework from your natural language processing frameworks means that most of your processing time gets spent and wasted serializing and deserializing and copying strings back and forth, and it can become highly inefficient. So this is actually a common side effect of using Spark MLlib. Not everything is possible with it directly, or not everything might be quite as mature as what you can find in, for example, SciPy or NumPy. Specifically to this regard, there are third-party libraries available specifically for natural language processing, such as the one I linked on the slide here, which is linking to the John Snow Labs. But anyway, don't let this information put you off. Though there are some limitations of using Spark MLab, it's still a very capable and very mature piece of software, and it covers a lot of ground. So what I will show you throughout this section is how we can handle natural language processing using the native libraries that Spark comes with, and which things it's capable of doing. So what does Spark offer in terms of natural language processing related functionality? So if you have another look in the feature module, which I introduced to you last section, we find that there are a few things in there that are of immediate interest to us. So I've linked a few here. For example, TF-IDF, the term factor and inverse document factor, which is nice. We can use that to calculate all sorts of things regarding natural language processing. Then there's word-to-fact, which means basically taking words and converting them to factors. Then there's a count factorizer, tokenizer. Tokenizer is there for hashing words up. There's stop words remover, which removes certain stop words in the language. N-grams, which means clumping parts of words together. So n-gram is, for example, a bigram is one of 2 words, and a trigram is one of 3 words. N-gram is an n number of words together as a group. Then there's the string indexer, which means you can cast indexes on strings and vice versa. Anyway, these are a few of the things that the feature module comes with, and a few of these we'll also be working with. There are some more hidden gems across there in MLlib, but we'll discover that as we go along. So what have we learned so far? So we learned that it's important to take a structured approach to data science and machine learning projects. I shared a model of how I approach this with you, and what we're going to do is we're going to be going through this model throughout this section. We're going to be building a real-time sentiment analysis system based on Twitter data. What I also showed you is what sentiment analysis is and how it fits into the larger world of natural language processing. And I've also introduced you to the fact that Spark has no dedicated library or dedicated module for NLP like it did with the recommender system. But it does have quite a few handy built-in features that we're going to be using.